Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Mind Maps, we're going to be dealing with the 5th chapter of the chemistry syllabus in grade 10 CBSE. Today, the chapter that we're dealing with is periodic classification of elements. So this chapter is a very important chapter because it's going to be further expanded in your future studies, so therefore it's very important to have a strong grip of this chapter. In order to revise this chapter for last minute preparations, the best way to deal with them is with mind maps such as this one. However, the problem here is that mind maps can be very extensive, and therefore this video is devoted to explaining them in some detail. Now, note that they're not just mind maps which help in last minute preparation, there are other tools as well, and we'll be dealing with some of them as well. So, the chapter that we're dealing with is the 5th chapter, periodic classification of elements. So, when we talk about classification, we talk about matter. So, matter in the universe is classified as elements, compounds, mixtures, etc. So elements are those pure substances with a similar chemical composition. Now, when we look at the total number of elements that we've discovered so far, there are 118 elements which are currently present in the world. And out of these, 94 of those elements are naturally occurring, and the others are man-made. Now, the problem with having more elements is that it is difficult to organize information about those elements. So if you have 118 elements, these 118 elements will have different properties and similar properties, so therefore it's very difficult to study them alone, to study them one by one. So in order to simplify this study, we have looked forward to classification. So classification is basically arranging similar objects or elements with similar properties together, and we find patterns in the elements that we have, and then we try to make sense of them. So in this chapter, we're going to be looking at the old theories, the history of periodic classification. Then we're going to be looking at the current accepted model, the modern periodic law. We'll look at the names of the groups, and we will look at periodic properties. So these are properties of the elements which are found in the periodic table, and we'll find out how they are varying with respect to the position of the element in the periodic table. So let's look at the old theories. Now, periodic classification didn't start overnight. There was a lot of research when it came to periodic classification, and one of the first attempts to create a periodic classification of all the elements present in that era was the Dobryner's Triad law. Now, in 1817, Johann Dobryner decided to classify elements in groups of 3, and these 3 elements would have similar chemical properties, and the group of 3 was called a triad. So the law here was about the law of the triads. Now, the law of the triads states that 3 elements which have similar chemical properties can be arranged in such a way that the atomic mass of the middle element is equal to the average of the atomic mass of the other elements, the other 2 elements. So, for example, we have calcium, strontium, and barium, which was classified by Dobryner as a triad. The atomic mass of calcium is 40.1 in the exact terms, 87.6 is the mass of strontium, atomic mass, and for barium it is 137.3. So now if we add 137.3 and 40.1, we get 177.4. So when we take the average of the masses of barium and calcium, so we divide 177.4 divided by 2, so you get 8, 16, 1, 8, 16, 1, 4, 7, so we have 14. So we would get 88.7 as the average of the masses of calcium and barium. Now, the mass of strontium is 87.6, so it's very close to the average of the masses of the other two elements. Now, this method was one of the first pioneering methods when it came to classification. However, the limitation for this method was that there were only 3 triads discovered. So that means that we could only classify 9 elements according to Dobrunner's law, and that wasn't equal to the amount of elements that was discovered at the time. So now we move on to the second attempt, the Newland's law of octave. This was formed in 1866. So the name of the scientist is John Newland, and John Newland's, he arranged 56 elements, which were the known elements at that time, in the order of increasing atomic mass. And his classification was very similar to music. According to him, when he arranged the elements, he found that every 8th element had properties similar to the first element. So this was similar to the concept of octaves in music, so therefore this was known as the law of octaves. Now, John Newland's method was revolutionary, but it had many limitations. The limitations here are that it was only applicable till calcium. So basically what that means is that Newland's arranged all the elements in order of their increasing atomic mass. However, in order to fully make it true, the elements have to have similar atomic properties according to the octave rule. That is, every 8th element had properties similar to the first. So this particular statement was valid only until calcium. After that, the elements did not have similar properties. Next, we had the problem of only 56 elements. So John Newland's predicted that there will only be 56 elements in the world, and he designed his table of octaves accordingly. So therefore, when new elements were discovered, it was found that they did not fit into the law of octaves. So therefore, Newland's law was dismantled. Another problem was that to fit elements, he put 2 elements in the same spot, and some of them had different chemical properties. So during classification, he took cobalt and nickel, which had similar properties, and put them in a column which contained fluorine, chlorine, and bromine. Now, fluorine, chlorine, and bromine have different properties compared to cobalt and nickel, so therefore this was incorrect. Next, we move on to the year 1901, when Mendeleev propagated his periodic law. Now, Mendeleev created the periodic table, the original periodic table, and he made the table in such a way that he had horizontal periods and vertical groups. Now, here again, the elements were arranged in order of atomic mass and chemical properties. However, Mendeleev's method was to find out groups of elements which had the same properties and then arrange all of them in such a way that their atomic mass were increasing. So the benefits for this method is that he did not assume that there were only 63 elements. He only said that there were more elements that can be discovered, and therefore blank spaces were put. Now, for some elements, he predicted the existence of some of the elements, such as silicon and gallium. So he put in placeholders for those elements, and he predicted their properties, and when these elements were discovered, it was found that they were similar to the properties that Mendeleev described. Now, another important property was that future elements were fitted without disturbing the order. So, even in the year 1901, we could not have discovered noble gases because they were inert. And so when noble gases were discovered, it was found that they could be easily added on to the periodic table by creating another group without having to disrupt anything else. So therefore, Mendeleev's work was very important. However, he still had limitations. The problem with Mendeleev's table was first the position of hydrogen. So hydrogen had properties similar to the properties of metals such as sodium and potassium. However, it also existed in a diatomic state such as the halogens like fluorine, chlorine, and bromine. So therefore, it was very difficult for Mendeleev to assign a position for H because his table was based on the properties and then the atomic mass. Another problem that Mendeleev faced was the existence of isotopes. Now, if you know what isotopes are, they are basically the forms of the same element but with different atomic mass. So according to Mendeleev's law, these isotopes are supposed to be separate elements, but they are not. And again, in some cases, Mendeleev had to separate similar elements and group them with other elements with different properties. So these were the limitations that Mendeleev faced. However, his work is very important, and it led to the arrival of the modern periodic table. So what was the step that made the modern periodic table as it is? In 1913, Henry Moseley found out that atomic number was the property to be used for classification. Now, if you know what is the atomic number? Atomic number is basically the number of protons that an atom has. So if you use the atomic number, it's found that you can actually classify elements better than using atomic mass. And you can also predict elements easily, because if you have a gap, then you can just find the atomic number of the previous element and add 1 to it in order to find this element. So Henry Moseley's work was incorporated into the periodic table, and then it created the modern periodic law. And the modern periodic law states that the properties of elements are a periodic function of their atomic numbers. So this is the same law that we use today. Now again, as with Mendeleev, the modern periodic table used vertical columns and horizontal rows. The horizontal rows are called periods, and the vertical columns are called groups. So this is a group, while this constituted a period. So we had group 1, group 2, group 3, group 4, and then we had 18 groups. We have 18 groups in total, And then we have 7 periods in the main periodic table. Also, we have 2 substitute ones, but then these will be studied in a higher grade. Now, using this periodic table, we have successfully classified 118 elements. And let's look at some of the groups which would be very important for your higher studies. First up, we have the alkali metals. Now, the alkali metals are found in the first group, which is this one: lithium, sodium, potassium, rubidium, cesium, and francium. So these metals had one valence electron, and therefore they had high metallic characteristics, and they were very reactive. Next, we have the alkaline earth metals. These are the second group, and they have 2 valence electrons. The boron family, which is group 13, had 3 valence electrons. The carbon family, which is group 14, had 4 valence electrons. The nitrogen family had 5 valence electrons. It's the 15th group. The 16th group is the oxygen family, which had 6 valence electrons. The fluorine family, which is called as the halogens, had 7 valence electrons, while the inert gases, or the noble gases, were classified under group 18, and they had 8 valence electrons. Now, groups 1, 2, 16, and 17 were highly reactive. In the case of groups 1 and 2, they had 1 and 2 valence electrons respectively, so they could easily lose their electrons. So they were very reactive. In the case of 17 and 16, they had 6 and 7 valence electrons, so therefore it was easier for them to grab 1 or 2 electrons to create a stable octet. So therefore they are also highly reactive. The 18th group is non-reactive. It's inert because all of the elements here have a stable octet, while groups 13, 14, and 15 resorted to sharing as well as ionic bonds. So therefore, these are the groups that we have. We also have elements which are present from 2 to 12, but then they have extra properties, and that has to do with how they are arranged in the table. So therefore, we'll study them in a future lecture, in a future grade. Now, let's look at the periodic properties. We have atomic radius, metallic character, nonmetallic character, chemical reactivity, ionization potential, electron affinity, and electronegativity as the periodic properties. So first up, let's look at atomic radius. So what exactly is the atomic radius? The atomic radius is defined as the radius of the atom. So if you take a circle, then its radius would give us an idea of how big the circle actually is. So when it comes to the periodic table, the elements here, the atomic radius varies with respect to the position of the element. The atomic radius decreases across a period, and it increases down the group. Now, across a period, there is more protons in an atom, while the number of shells or orbits of the electron are still the same. So even though there are more number of electrons, the number of orbits stay the same. So the extra number of protons would ensure that the atomic radius decreases. However, as we go down a group, we can see that new shells are added. So down the group, we have the same electronic configuration. We have one valence electron across all the elements of the first group, but that valence electron is in a different shell. So as we go down the group, the shell gets bigger, and therefore the atomic radius increases. Let's look at metallic character. Now, metals have the chemical property which is the tendency to lose electrons. So basically, the term metallic character refers to the tendency to lose electrons. Now, when we look at the periodic table, the metallic character decreases across a period. Now, the reason for this is that there are more valence electrons as we move across a period. So lithium has 1, beryllium has 2, boron has 3, carbon has 4, nitrogen has 5, oxygen has 6, fluorine has 7, neon has 8. So as you can see, if you have more valence electrons, it becomes difficult to lose all of the electrons to gain a stable octet. So therefore, the metallic character decreases across a period. Now, what about the metallic character down a group? It increases. So when we go down a group, we have the same number of outer electrons. We have 1 valence electron across the first group, 2 valence electrons across the second group. But then there is the addition of new shells. So when we have new shells or orbits of electrons, as we move down the group, the atomic radius increases. And that means the attraction between the protons and the electrons decreases. So therefore, that makes it easy for the element to lose an electron. So therefore, its metallic character increases. Now, let's look at some other properties: nonmetallic character, as well as chemical reactivity. So what is nonmetallic character? Chemically, nonmetals have a tendency to gain electrons. So nonmetallic character refers to the tendency to gain electrons. Now, the nonmetallic character increases across a period because it has more valence electrons. So when you have more valence electrons, such as in the case of oxygen and fluorine, it's easier for them to gain an electron instead of losing 6 or 7. So therefore, the nonmetallic character increases across a period. However, it decreases down the group, and that has to do with the number of new shells that are formed. So let's take the 17th group, halogens. So in halogens, fluorine has the least amount of shells, while iodine has the most amount of shells. Now, when iodine has a larger shell, this means that there is a shielding effect of electrons present before the valence shell. So that makes it difficult for an electron to go inside the outer shell in order to complete the octet. And that's why the nonmetallic character decreases down a group. Now, what is chemical reactivity? Now, metallic character is the tendency to lose electrons. Nonmetallic character is the tendency to gain electrons. But in a chemical reaction, we have elements which transfer electrons to become stable. So chemical reactivity basically is the tendency to react. And most reactions are ionic, so therefore that means they involve transfer of electrons. So since this requires a transfer of electrons, chemical reactivity is dependent on nonmetallic and metallic characters. So if you look at across a period, it first decreases and then increases. So basically what that means is that first we find that the metallic character decreases across a period. So as we move along 1, 2, 13, and 14, the reactivity decreases. But by this time, the nonmetallic character has sufficiently increased in order to increase the reactivity. So 15, 16, 17 would have higher reactivity. These groups would have higher reactivity. So therefore, the reactivity decreases and then increases across a period. Now, as we move down the group, it depends on whether the elements are metals or nonmetals. For metals, the metallic character increases down the group, so therefore their reactivity increases. For nonmetals, nonmetallic character decreases down a group, so therefore the reactivity also decreases. Now let's look at some other periodic properties. First up, we have electronegativity. So what is electronegativity? Well, electronegativity is basically the tendency of an atom to attract shared electrons. So basically this has to do with covalent bonds. So in covalent bonds, atoms, instead of gaining or losing electrons, they share electrons with one another in order to create a bond. So to attract shared electrons with another atom towards itself. So for example, if we have water, in water we have oxygen atoms sharing their electrons with hydrogen atoms. But if you look at water, you can see that oxygen has higher electronegativity. So therefore, it attracts all the shared electrons towards itself. So that is the concept of electronegativity. Now, electronegativity decreases down the group because, well, if we go down the group, we have bigger shells and also shielding effect which takes place. So therefore, that reduces the electronegativity. However, electronegativity increases across a period, and that has to do with amount of protons present in the nucleus. So you have more protons in the nucleus, but the shell number remains the same, so therefore attraction increases. Now let's look at electron affinity. The electron affinity is basically the amount of energy released when atom is changed to negative ion. So basically that means the amount of energy required to be released when an electron is taken into a neutral atom to make it a negative ion. Now, electron affinity again decreases down the group, and this is because of the shielding effect of inside electrons. On the other hand, it increases across a period, and this is due to the presence of more protons in the nucleus compared to the shells. Now, ionization potential is defined as the minimum amount of energy required to remove one valence electron. Now, the ionization potential decreases when we go down the group because we have a bigger shell as we move down the group. So the shell number gets increasing. So therefore, in bigger shells, the shielding effect and the presence of a bigger shell means that it's easy to remove an electron. So therefore, it decreases down a group. Across a period, the ionization potential increases. So that means it requires more energy due to the fact that the attraction between the protons and the electrons increases due to the increasing number of protons. So those are the periodic properties, the main periodic properties that you'll be studying in this chapter. So that concludes the mind maps. Now we're going to be looking at some other methods of acing last-minute revisions. One of these are flowcharts. So if we look at a flowchart for the classification of elements, we basically have flowcharts related to the history of classification. So first we have arranged with increasing mass, groups of 3 elements leads to Joubrenas triads, main features being the middle element's atomic mass is the arithmetic mean of the atomic mass of the other 2 elements. Now it had some limitations, and that led to Newland's octaves. It was workable until calcium out of the 56 elements discovered. And main features being every 8th element had properties similar to that of the first, but again it had a lot of limitations, and therefore it led to Mendeleev's periodic table, which was able to classify 63 elements at the time, arranged with increasing atomic mass, the features being elements arranged in vertical groups and horizontal periods. This led to easy addition of new elements. However, more research found limitations, and that led to the modern periodic table, which now holds 118 elements, and the difference here is that it's arranged with increasing atomic number. Again, main features being elements arranged on the basis of electronic configuration into 4 groups, and also it takes features from the Mendeleev's periodic table as well. So that concludes this episode of Mind Maps. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a lot of episodes regarding mind maps for grade 10. If you want to access those, please hit the link for that playlist in the description down below. So, until the next episode, take care, stay safe, bye-bye for now.